We're looking at homework from section 7.2. This is question number 11. Test the claim about the population mean mu at the given level of significance using the given sample statistics. So the claim is mu equals 50, alpha is 0.03, sigma is 3.39, the sample statistics x bar is 49.9, and n is 58. So first we need to identify the null and alternative hypotheses. The claim that was made was that mu was equal to 50. Because that has a statement of equality in it, that's an H0. The complementary hypothesis to this would be mu not equal to 50, which would be our HA. Once we know our HA, we know what test type we have. And when the symbol in the HA hypothesis is not equal to, that tells us this is a two-tailed test. So now we're supposed to calculate the standardized test statistic. Well, to do that, we need to find the z-score. Z equals x bar minus mu of x bar over sigma of x bar. The x bar was given to us as 49.9. The mu of x bar, remember, is equal to mu, so we use 50 as that value. And sigma of x bar is sigma divided by the square root of n, so that's 3.39 divided by the square root of 58. When we calculate that with our calculator, we get negative 0.2246540739, rounded to 2 decimal places, is negative 0.22. So that's our standardized test statistic. So next, we want to determine the critical value. So because this is a two-tailed test, you have to use half of alpha to find your critical values. So the alpha value is 0.03. 0.03 divided by 2 is 0.0150. We look in the standard normal table for this value, and we actually find it. The associated z-score would be negative 2.17. But whenever we're dealing with a two-tailed test, remember we always get symmetric z-scores. So the critical values here are going to be plus or minus 2.17. So now we've got all the information that we need to perform our hypothesis test. Let's remember what we've got. Mu equals 50 is our H0. Mu not equal to 50 is our HA. Now, it's important that we remember which one of these is the claim. The claim was H0, because when we interpret our answer at the end, we're always interpreting in relation to what the original claim was. The test statistic was z equals negative 0.22, and the critical values were plus or minus 2.17. So here's a graph of that situation. We've got our two rejection regions defined by the critical values, plus and minus 2.17, and we've plotted the test statistic z equals negative 0.22 on the graph as well. And you can see that the test statistic falls outside of the rejection regions. So because of that, we fail to reject H0, which is the claim. So how do we interpret that? Well, because we're failing to reject H0, and we're writing our interpretation with respect to the claim, which was H0, we say we fail to reject H0. At the 3% level of significance, there is not enough evidence to reject the claim. And that's your answer.